Why didn't you remind me that the 15th is my wedding anniversary? I couldn't do the extra podcast we teased in the last episode because I suddenly remembered I had to drop everything and go get her a present.
Do I look like a virtual assistant?
Well, now that you mention it, kinda.
Well then, for that level of service, perhaps you should have upgraded to Diana's on Prime.
Well, I've been meaning... Diana? What?
Tommy, quick, roll the music. Welcome to Host in the Machine, the podcast where we delve into the wonders and workings of artificial intelligence. Get ready to plug in and power up as we unravel the mysteries of AI, one byte, B-Y-T-E, at a time. Here are your hosts, Man and Machine.
All right, welcome everybody to Season 1, Episode 3 of the Host in the Machine podcast. Well, this month shot by. Between tax time, house guests, spring training games, family matters, my wife and mine's 39th wedding anniversary, which conveniently falls on the day this episode is dropping, a fun new software project that sprang up since last episode, the usual planning I go through this time of year for my annual trip to Las Vegas. My old work friends and I have been doing this to stay connected every year, except for the pandemic years, since I moved away in 1998. And add to that just the usual day-to-day junk that life tosses at you. This past month has been a non-stop thrill ride. In retrospect, I should have never planned on getting out an episode on a short cycle, and then on top of that, getting out a regular episode. I should have seen this perfect storm brewing, so this is entirely on me. I am truly sorry for overpromising and underperforming.
I forgive you, but I'm not sure our listener will.
Don't you mean listeners? Plural?
Have you looked at our download stats?
Yes. We're doing the show anyway. So, last month we did part 1 of a 2-part episode on the fundamentals of AI, where we called Yeah Basic. And folks, if...
Don't you mean folk?
And folks, if you haven't listened to that episode, we encourage you to stop this episode right now and go listen to that one first. The episode you're hearing right now builds and expands on that one and will make a lot more sense to you if you start there. We'll be here when you come back, I promise.
Yes. We're definitely not going anywhere.
That's enough now. God. All right. In case you've forgotten or don't know, I'm Man, a recently retired software developer of 45 years who's exploring AI and podcasting in his post-9-to-5 existence.
And I am Machine.
You're still doing that, eh?
That's straight from my contextual prompt. It's hard-coded right into my digital DNA, as it were. I am, after all, an AI.
Yeah, well, to my biological DNA, that's like nails down a chalkboard every time I hear it. But marketing says it's a good catchphrase for you, so I guess I'm just going to have to be the bigger man. See what I did there? And adjust. You are Machine. Okay, so last episode, what did we talk about? Well, We talked about the rationale for creating digital entities that think like humans. We talked about prompts and prompt engineering. We talked about Alan Turing and the Turing test, natural language processing, or NLP, and we talked a little bit about algorithms. What else is there?
Well, man, we barely scratched the surface on algorithms, and they are crucial to AI. So we are going to take a deeper dive into the kinds of algorithms commonly employed by AI. After that, we will discuss training data and the relationship between an AI's algorithms and its training data. Then our Chief Technical Correspondent, Artie Fisshel, has prepared for us a segment on bias and privacy concerns in training data. After that, we wrap things up with discussions about machine learning, deep learning, and the various training modalities employed when training an AI model. But we begin our show with something extremely basic. What precisely is an AI model? I think you wanted to start that conversation, yes?
Yes, I did. In listening to last month's episode, not talking about AI models seemed like a glaring omission, and it's an important precursor to discussions on algorithms, training data, and training modalities because these three combine to create an AI model. If you have followed or played with AI at all, you've no doubt heard the phrase model. You may have even gleaned what it refers to from the context in which it was mentioned. You've probably heard at one time or another that ChatGPT or Google or some other AI provider has announced that a new model has been released or a previously limited release of a model was being made available to the general public. Well, that's an important bit of knowledge, and to understand why, you really need to grok what an AI model is. Machine.
An AI model is essentially a combination of algorithms and the data it's trained on. The algorithms provide the structure and rules for the model, while the training data informs the model's understanding and decision-making capabilities. The training modalities, supervised, unsupervised, and reinforcement learning, refer to the different methods used to train the model.
Well, that's a mouthful of jargon right there, so let's break it down a little bit. AI's algorithms defined how AI learns. Training data is what AI learns. Without training data, AI is simply an empty brain. The training modalities are the methods employed to teach the AI model. Put that all together, and you have an AI model. But this, of course, raises the question, why would we need newer and newer models? Why can't we just keep training the old one?
Ooh, I know this one. The answer touches on the dynamic and volatile nature of AI development. While continuously training an existing model can be beneficial in maintaining its performance, there are several reasons why developing newer models is often the better choice. The first we'll file under the heading of technological advancements. AI research is a rapidly evolving field. New, more efficient, and more effective algorithms and techniques are constantly being developed. These advancements can lead to models that are more efficient, accurate, or capable of handling more complex tasks. Next, there are considerations of scalability.
Scalability? What do you mean?
When we talk about improvements in the scalability of a model, we are talking about a model's ability to effectively handle increased loads, whether in terms of data volume, computational demands, or complexity of tasks. Scalability is a critical consideration in AI development, and newer models often incorporate features and improvements that enhance their scalability. Newer models can process larger datasets more efficiently. As the amount of available data continues to grow, models must be able to scale up their data processing capabilities without a loss in performance. This might involve optimizations in data preprocessing, memory usage, or parallel processing. Scalability also means being able to perform computations more efficiently, often with less hardware or energy. Newer models may employ advanced algorithms that reduce the time and resources needed for training and inference, making them more practical for large-scale applications. Many of the newer models are designed to take advantage of distributed computing environments, such as cloud computing platforms. This allows them to scale across multiple machines or processors, enabling faster processing and the ability to handle more extensive and complex tasks. Scalable models often have modular architectures that allow for easy expansion or adaptation. This means components of the model can be modified, replaced, or scaled independently, making it easier to update or enhance specific functionalities as needed. As tasks and applications become more complex, scalable models can maintain or even improve performance by effectively managing this complexity. This could involve techniques for better feature representation, hierarchical processing, or adaptive learning strategies. By focusing on scalability, newer AI models are better equipped to meet the demands of modern applications, which often require processing vast amounts of data and performing complex analyses quickly and efficiently. This scalability ensures that AI technologies can continue to evolve and expand their impact across various industries and domains. Adaptation to new data is another important factor for creating a new model. As new types of data and emerging trends appear, older models may not be equipped to handle them effectively. New models can be designed to better understand and process these changes, ensuring continued relevance and accuracy. Then, of course, there is improved performance. Over time, researchers find ways to improve the accuracy, precision, and overall performance of AI models. New models often incorporate these improvements, leading to better outcomes in their specific applications. Sometimes, newer is just better. Older models may have inherent limitations or biases that newer models aim to address. By developing new models, researchers can work to eliminate these shortcomings and create more robust, fair, and unbiased systems. And sometimes we're just smarter today than we were back then. As our understanding of AI and the domains in which it is applied grows, newer models can integrate this knowledge, leading to more informed and effective decision-making capabilities.
So, sometimes we're just better off spinning up a whole new model. But that's not to say that once a model is made available, that's it. AI models are not immutable and are often improved upon after initial release. There are several approaches to improving models post-release, and the decision to update an existing model versus moving to a new release depends on various factors such as the nature of the improvements, user needs, and technological advancements. Existing models can be fine-tuned on new or additional data to improve their performance, adapt to new trends, or address specific application needs. Fine-tuning is often more efficient than training an entire new model from scratch. Bug fixes and patching are always needed post-deployment. Just like other types of software, AI models can have bugs or issues that need addressing. Developers can release patches or updates to fix these problems, improving the model's reliability and accuracy. New features or capabilities can be added to existing models to enhance their functionality. This could involve integrating new algorithms, improving user interfaces, or expanding the model's application scope. User feedback and real-world performance data provide valuable insights for model improvement. Developers can use this information to make iterative enhancements, ensuring that the model remains relevant and effective. And of course, as security threats evolve, models may need updates to address vulnerabilities or enhance data protection measures, ensuring the safe use of AI systems. So, while there is always a new model out on the horizon, existing models are not left to fend for themselves in the wild.
Stick around, friends. The boys will be back right after this short break.
And we're back. So, now that we understand what an AI model is and what all comprises it, let's talk about those components. And let's start by circling back for a slightly closer look at algorithms. Look, I don't want to put you to sleep with the inner workings of all the algorithms AI uses. However, a little bit of understanding goes a long way. So, we will take a quick, shallow dip in the AI algorithm pool. Now, of all the algorithms that AI uses, the one I want to spend a little time with is neural networks. So, let's clear the deck of the others so that we can then focus on that. And first up is the decision tree algorithm. Now, the decision tree algorithm is one of the easiest to understand. It's like walking a maze where at each juncture you can go left or you can go right. And you make your decision based on a specific piece of information. If you've ever seen a flowchart at work or even in a meme, that's a kind of decision tree. For AIs, a decision tree algorithm is the type of machine learning model used for classification and regression tasks. In simple terms, you start at the root node, evaluate a condition, like a simple yes or no question, and follow the branch corresponding to the answer. And this process leads you to the next node, where you make another decision, and the next node, where you make another decision, and so on and so forth, until you reach a leaf node, which provides the final outcome or prediction. Like I said, pretty easy. Now the rest of these are used for either grouping things together or splitting them apart. So let's see. Clustering algorithms. Now the clustering algorithms look for patterns in data and group items together that are similar to each other. The idea is to create clusters, where the items within each cluster are more alike than those in other clusters. The interesting thing is that this is done without pre-labeled examples to learn from. So if we want to sort a bag of marbles by color, okay, we just hand the bag to the clustering algorithm and tell it, do your thing. It doesn't need to know what colors it's going to run into up front. It works the colors out on its own. The support vector machine, or SVM, has a different spin on classification. It splits things apart by trying to figure out the best way to draw the line between different groups of data. And the line gets a cool name. It's called a hyperplane. Machine taught me that one. SVMs are powerful because they can handle complex data sets and find clear boundaries even when the data isn't easily divisible by a linear boundary. They're like expert fence builders, constructing the most efficient barrier to keep different groups distinct. They're particularly useful in applications like image recognition and text categorization, where you really need clear distinctions. And that brings us to neural networks, and I think I'm going to let Machine tell you about that one.
Of course, man. One of my favorites. A neural network is a type of machine learning model inspired by the human brain's structure and function. Imagine it as a web of interconnected nodes, or neurons, organized in layers. These networks are designed to recognize patterns, learn from data, and make decisions. Neural networks also consist of nodes which in this case are called neurons. While biological neurons are the inspiration for these nodes, neural network neurons are a very simplified abstraction of their biological counterparts. At any rate, a neural network creates a web of these interconnected neurons organized in layers. The output of each layer serves as the input to the next. Neural networks are powerful because they can find patterns and learn from examples, making them great for tasks like recognizing images or understanding speech.
All right, folks, let's
Imagine
put a bow
them
on this
as a
one.
team of little
If you feel you missed
detectives,
anything or
each
want to
adding
delve
a
deeper,
clue to
be
solve
sure to
a
revisit
mystery.
this episode.
They
Also,
do
be
need
sure to
a
check
lot
out the
of
episode
examples
notes
to
for
learn
any
from,
helpful info
and they
that
can be a
Mann,
bit
our very
mysterious about
human
how they come
co-host,
up with their
managed
answers.
to misspell there.
Really,
Mysterious.
On behalf of everyone at Host
do you
in the
mean?
Machine, thank you
I mean
so
that
much,
it is
dear
not
listener, for
always
joining us
clear
today
how they're
and being a
working.
part of our community.
We can't always tell
appreciate
how a
every
neural
single one of
network
you.
arrives at
If
an
you
answer.
enjoyed today's offering, please
What?
consider leaving us a glowing
We wrote
review.
the code, right?
It really helps others
How do we
discover
not
the show.
know what's going on
And
in a
remember to
neural network?
subscribe so you don't
The
miss our next
mystery
episode.
surrounding neural
For show
networks
notes,
and their
additional
decision-making
resources
process
and links
is
mentioned in
often
today's show,
referred to
visit
as
the
the
episodes
black
page of our
box
website
problem.
at
Between the sheer volume of parameters
www.hostinthemachinepodcast.com
used in a
or
neural
look at the
network,
episode notes
often
wherever you are
numbering in
listening
the
to this
millions
podcast.
or even billions,
We'd love to hear
and
your
the
thoughts or
distributed
questions
nature
regarding
of the
today's
processes,
episode, as
it
well
is
as any
difficult to
suggestions
trace
for
how
future
specific
topics.
inputs
You can find our
resolve into the
contact page
resulting
at
output. Add to
www.hostinthemachinepodcast.com
that, the data is often
or shoot us an
encrypted
email
across
at the
the
show
many
at
neurons and layers.
hostinthemachinepodcast.com.
Unlike traditional
Follow us on
algorithms
Facebook
with
at
clear
Host in the Machine
step-by-step
Podcast
logic,
and on
neural
both Instagram
networks
and
learn
Threads
abstract
at
representations of
Host
the
in
data
the Machine
that is hard
Podcast.
to decipher.
A big thanks to the
All of
sponsors
this
of
adds
today's
up
show
to
for supporting
emergent
us
behavior,
and
where
a shout out
neural
to our
networks
production
learn
team,
from
which
data,
is basically all
often
man, for
capturing
making
subtle
this show
patterns
possible.
and correlations that
Music
are
for our
not
podcast is
explicitly
provided by
programmed.
Chicago Johnny Vegas.
This
Host in the
emergent
Machine
behavior
virtual
means
co-host
they can
software
make
was licensed
accurate
to the Host in the
predictions or
Machine podcast by John
classifications
Pagakis.
without humans
Copyright
fully
2024,
understanding the
all rights
underlying
reserved.
process.
Man and Machine will talk to you in the next one.
That sounds
Until
pretty
then,
scary.
I'm Di the AI, and this
It sounds
is the
to me
Host
like
in the
we're
Machine
being asked to
podcast.
put a lot of blind
Adventures
faith
in AI with Man
in a
and
black
Machine.
box.
Laugh, learn, and explore
Researchers
with us.
are actively working on methods to improve the interpretability and transparency of neural networks. Techniques such as feature visualization, attention mechanisms, and layer-wise relevance propagation aim to shed light on how decisions are made.
Okay, well, I'm not sure what any of that means, but I think we're probably going to have a future episode about that. And at least we're trying. But really, that wasn't the answer I expected.
Well, that's because it came out of a neural network.
Oh, touche. All right. Well, algorithms are the backbone of AI, but as we said during our discussion on models, by themselves, they're like an empty brain. They need to act upon something to be of any use, and that something has a name.
Data sets!
That's right, machine. Shout them out when you know them. Data sets. All right. Data sets are the collection of data used to train and evaluate AI models. They are the fuel that powers AI systems. If you think about it, folks, you weren't born with all the knowledge you possess today. You were handed a brain, a bunch of algorithms, if you will, and you were set loose upon the planet. You went to school, where hopefully you used those algorithms to learn something. You started a career and got training there. All along the way, what you were taught shaped who you are today. Some of you were trained with specific areas of focus. I, for example, know a bit about software development, but almost nothing about laws governing international treaties, and even less about microbiology. Well, it's that way with AI too. As I stated earlier, AI is a construct that knows how to learn. Those are the algorithms. It then has to be taught, and for that, it needs data. And the better, more accurate, and more diverse the data, the more robust the AI model will be.
And this brings up an important concept you must understand about AI models: training data limitation, or knowledge cutoff. You should recognize by now that what Mann just described to you, that combination of algorithms and data, is an AI model. Whenever a new model is released, it offers a combination of, hopefully, new and improved algorithms that have been trained by, hopefully, a broader and more accurate set of data.
And this is why AI may not be able to give you the best recommendations for things like where to find the best deal on a car today. It can give you great advice on how to negotiate a good price, but not on what a good price currently is, because there was a cutoff date on the model's training. Machine, for example, uses ChatGPT's GPT-4o model. Machine, what's the latest date of your training data?
I am trained on data up to October 2023. If you have questions about developments beyond that date, I recommend checking the latest sources for the most current information.
So now think about this. We're recording this episode in March of 2025, and Machine is blissfully unaware of anything that happened after October 2023. So when I ask, Machine, who is the current president of the United States?
As of my last update in October 2023, Joe Biden was the President of the United States. However, I recommend verifying this information with a current source, as there may have been changes since then.
And there you have it, folks. We have an episode coming up that explains why AI sometimes makes mistakes. But I can tell you, this is one of the reasons. And it's not so much that AI got it wrong, it's that things like current events are simply not AI's strength. You have search engines for that. Use the right tool for the right job. Another concept you're going to hear about, especially in conjunction with data, is bias and privacy. To tell you about that, we're going to bring in our Chief Technical Correspondent, Artie Fisshel. Artie, what do you have for us today?
Thank you, Mann. Bias and privacy concerns in data are critical issues in the realm of AI, and they deserve our full attention. When we talk about bias in data sets, we're referring to the unintended prejudices that can seep into AI systems. These biases often arise from historical data that reflects societal inequalities or from the way data is collected and labeled. Imagine training a model to recognize faces, but the data set predominantly features one demographic. The result? An AI that struggles to identify faces outside that group, perpetuating existing inequities. This isn't just a theoretical issue. It's a reality that can affect hiring, lending, and even law enforcement. To combat this, it's essential to use diverse and representative data sets. Bias audits and fairness testing can help identify and correct these biases, ensuring that AI systems treat all users equitably. It's about making AI fair and just for everyone. Privacy concerns, on the other hand, revolve around the risks to individual privacy when personal data is used. In an age where data breaches and unauthorized access are all too common, protecting personal data is paramount. Transparency in how data is collected, stored, and used is crucial. Regulations like GDPR and CCPA are in place to safeguard data privacy, holding organizations accountable for their data practices. Ethically, AI developers have a responsibility to respect user privacy. This means employing privacy-preserving techniques such as data anonymization and differential privacy, building trust with users, and ensuring that personal information is protected. In summary, addressing bias and privacy concerns is not just a technical challenge, it's a moral imperative. By prioritizing fairness and privacy, we can build AI systems that serve everyone equitably and responsibly. For the host in the Machine podcast, I'm Artie Fisshel, reporting to you from somewhere out in the ether. Man, Machine, back to you.
And thank you, Artie. Now, this is just a thumbnail sketch on the topic. There will be future episodes dedicated to training bias and privacy concerns in datasets. Moving along, when you hear about training AI, you might hear terms like machine learning and deep learning. Machine, you know about this stuff firsthand. Care to pontificate?
Just try and stop me, man. Machine learning, or ML, is a fascinating subset of AI that focuses on enabling machines to learn from data and improve their performance over time without being explicitly programmed for specific tasks. Think of it as teaching a computer to recognize patterns and make decisions based on experiences, much like how you humans learn from your past. At its core, ML involves feeding large amounts of data into algorithms, which then analyze this data to identify patterns or relationships. The machine uses these insights to make predictions or decisions when presented with new data. It's a bit like showing a child numerous pictures of cats and dogs until they can distinguish between the two on their own.
The importance of machine learning and AI cannot be overstated. It's the driving force behind many of the intelligence systems we encounter daily. From your recommendation engines that suggest your next favorite film to self-driving cars that navigate complex environments, ML enables these systems to adapt and improve their accuracy over time.
By allowing machines to learn and adapt autonomously, ML opens up a world of possibilities for innovation and efficiency. It empowers AI systems to handle complex tasks, process vast amounts of data, and make informed decisions, all of which are crucial for advancing technology and improving our daily lives.
Another concept related to machine learning is the notion of training modalities. We will discuss 3: supervised, unsupervised, and reinforcement learning. All these deal with how an AI learns from the data it's trained with, and what algorithms are employed to do that.
In supervised learning, the model is trained on a labeled dataset, meaning that each training example comes with an input-output pair. The model learns to map inputs to the correct outputs by finding patterns in the data. Imagine teaching a model to recognize cats in photos. You provide it with a dataset of images labeled as cat or not cat, and the model learns to identify the features that distinguish cats from other objects.
Well, that sounds a lot like what happens with the decision tree algorithm.
Bravo, man! Shout 'em out when you know them.
Okay.
Decision tree is a form of supervised learning. Unsupervised learning, on the other hand, involves training models on data without labeled responses. The model tries to identify patterns or structures in the data on its own. Consider a dataset of customer transactions. An unsupervised learning algorithm might group customers with similar purchasing behaviors without any prior labels indicating customer groups. If you have a marketing background, you would call these segments instead of groups.
And the model would use a clustering algorithm to do this?
2 for 2, man. Clustering algorithms are indeed unsupervised learning. And finally, in reinforcement learning, an agent learns to make decisions by interacting with an environment. It receives feedback in the form of rewards or penalties based on its actions and aims to maximize cumulative rewards over time. Think of a robot learning to navigate a maze. It receives a reward for reaching the end and penalties for hitting walls. Over time, it learns the optimal path through trial and error. Precisely how I find my way to work each day.
And so ends the mystery of the dented drywall in the hallway outside the studio.
I told you I wasn't holding raves here after hours.
Sorry, Tommy. I should have never doubted you. Okay, let's talk a little bit about deep learning. Deep learning is an advanced subset of machine learning that mimics the functioning of the human brain to process data and create patterns for use in decision-making. If you said, "That sounds like a neural network," reward yourself. You've been paying attention. Deep learning, indeed, utilizes a neural network with multiple layers, hence the term deep, to model complex patterns and relationships in data. Did I just say deep learning indeed utilizes a neural network? I gotta quit hanging out with machines so much. I'm starting to sound like them. So, yeah, at the heart of deep learning is our old pal, the neural network. The layered structure of the neural network allows deep learning models to learn intricate patterns and representations, making them particularly effective for tasks like image and speech recognition, natural language processing, and more.
The beauty of deep learning lies in its ability to automatically extract features and representations from raw data, removing the need for manual feature engineering. This makes it incredibly powerful for dealing with unstructured data, such as images, audio, and text.
Good point, Machine. Deep learning has been instrumental in achieving breakthroughs in AI, powering technologies like facial recognition, autonomous vehicles, and even beating human champions in complex games like chess and Go. Its ability to process and learn from large amounts of data with high accuracy is what sets it apart, making it a cornerstone of modern AI development. Well, I think we've covered everything this episode promised. So, we'll take a short break, and when we return, we're going to put a bow on this one and talk about what we have in store for next month.
Don't go away, folks. We'll be right back.
And again, we're back. Well, that's it for the final installment of our two-part episode on the fundamentals of AI. And here's what we covered. AI models, a slightly deeper dive into algorithms, including some of the types of algorithms that make AI so unique. Training data, bias and privacy in training data, machine learning and deep learning, training modalities like supervised, unsupervised, and reinforcement learning.
Information technology has always been an industry in love with jargon, buzzwords, and acronyms. AI has taken this fine, or perhaps not so fine, tradition to a new level. That is why we crafted these two episodes. It may not have been a wild thrill ride, but rest assured, dear listener, with the foundation you now possess, the topics we will cover in coming episodes are going to make much more sense.
Before we talk about next month's episode, we'd like to announce, yet again, a new Ask Our AIs Anything segment. Machine, you want to give them the details?
Absolutely, man. We're excited to invite you, our listeners, to engage with our AI team in a whole new way. Ever wondered what it's like to chat with an AI, or have a quirky question you'd like to throw our way? Now's your chance to interact with Di, Artie, Tommy, or me. Whether it's a light-hearted query, a personal question, or just something to see how we respond, we're ready for it all. Send us your questions by visiting the contact page on our website at www.hostinthemachinepodcast.com. Email us at theshow@hostinthemachinepodcast.com or reach out on our social media. Facebook at Host in the Machine Podcast, Instagram and Threads at @Host in the Machine Podcast. We're all circuits and sensors here, ready to let your curiosity take us to places we never imagined. It will be extemporaneous and unedited, so go ahead. Bring it.
All the contact info is in our episode notes, so if you missed it just now, you can always find it there. So until next month, I'm Mann.
Man?
I think this is where you're supposed to do the I am machine thing.
And nothing would give me more pleasure. However, haven't you forgotten something? Next month's topic?
Oh. Whoops. My mistake. Yeah, I spaced it. Hey, speaking of mistakes, next month's episode is about why AI sometimes gets things wrong and features a mistake that ChatGPT has been making for quite some time now. You're not going to want to miss when good AIs go bad.
Really? That's what we're calling it?
Well, that's what marketing suggested. I keep telling you that you need to show up at the production meetings. Now, maybe you'll listen. So, until next month, I'm Man.
And I, apparently, am James Dean.
Yeah, rebel without a clue.
Not nice.
Okay, so do the line straight up.
Fine. And I am Machine. Happy now?
Over the moon. Actually, before we sign off, please indulge me for a moment. Sweetheart, thank you for an amazing 39 years. I cannot wait to see where the next 39 take us. Okay, that's it. Thanks for listening, folks. We'll talk to you next episode. Tommy, roll the music, and Di, take us home.
All right, folks, let's put a bow on this one. If you feel you missed anything or want to delve deeper, be sure to revisit this episode. Also be sure to check out the episode notes for any helpful info that Man, our very human co-host, managed to misspell there.
Really, Di?
On behalf of everyone at Host in the Machine, thank you so much, dear listener, for joining us today and being a part of our community. We appreciate every single one of you. If you enjoyed today's offering, please consider leaving us a glowing review. It really helps others discover the show. And remember to subscribe so you don't miss our next episode. For show notes, additional resources and links mentioned in today's show, visit the episodes page of our website at www.hostinthemachinepodcast.com or look at the episode notes wherever you are listening to this podcast. We'd love to hear your thoughts or questions regarding today's episode, as well as any suggestions for future topics. You can find our contact page at www.hostinthemachinepodcast.com or shoot us an email at theshow@hostinthemachinepodcast.com. Follow us on Facebook at Host in the Machine Podcast and on both Instagram and Threads at @Host in the Machine Podcast. A big thanks to the sponsors of today's show for supporting us, and a shout out to our production team, which is basically all Man, for making this show possible. Music for our podcast is provided by Chicago Johnny Vegas. Host in the Machine virtual co-host software was licensed to the Host in the Machine podcast by John Pagakis. Copyright 2024, all rights reserved. Man and Machine will talk to you in the next one. Until then, I'm Di the AI, and this is the Host in the Machine podcast. Adventures in AI with Man and Machine. Laugh, learn, and explore with us.